Hey everybody, welcome to Immerse Games live stream yet again with the advent of new productive technologies.
You can't keep us from adding new productive technologies and live streaming it to all of our fans.
We're trying to make it better. Yeah, we're here with another stream every 2 weeks like we always do, and I don't know what we're showing off. I'm just as oblivious as the viewers are.
It seems that I am the only one who knows what we're showing off today. What will I do with this power? I'll probably show you what I want to show you guys.
It's like the only thing you can do.
All right. So we're going to be going through some Heredity quests today. We are going to be going to Espeth Park and to the Academy to learn some stuff about Heredity. So let's be on our way to Espeth Park.
Oh, I can't wait. Oh wait, is this going to be with Dog Lady?
Spoilers, Kevin.
Is Dog Lady fixed? Well, that's a sign of confidence. That's the voice of confidence right there. Look at that ocean.
That's a beautiful ocean.
That could be better. No, wait, keep walking to the Dog Lady.
I'm walking. All right.
Wait, she's over here now?
Yes.
Oh, you moved her.
All right. So some players may recognize dog walker Claire Madeline. She used to be way over there, somewhere in the trees where it was very hard to find her. I have moved her to this more convenient location.
Oh.
She has been in the game since the game launched, but this is her first quest, so congratulations, Claire Madeline. Claire Madeline is a Kickstarter backer, so thank you for that, and here is your quest. As you can see, she has two dogs that she's walking. Their names are Parker and Watson. And, whoops. I'm super busy at the moment. I'm introducing this quest. Be quiet.
Looking at your dogs.
Looking at your dogs, man. So this is Parker. Parker is the dog of one of our Kickstarter backers. The late dog of one of our Kickstarter backers, but he looks like a very good boy, and he is a border collie standing right there. And Watson is his friend. She was added for this quest. She is also a border collie with a very special gene, which we'll learn about soon.
Does that have to do with her eyes?
Maybe, Kevin.
Hey man, I'm just learning as I go. I don't know what's happening. Oh shoot.
A little bit of background on Watson's name. I was pretty pleased when we were trying to figure out what to name this dog. We were gonna name her like Posey or something.
That's a good name.
We decided on Watson. And at first it was because, of course, Sherlock Holmes's dear friend Watson, who accompanies him on all of his mysterious adventures. So
Wait,
that's.
But then what's the first dog's name?
The first one's name is Parker.
So, where does the Sherlock Holmes interplay?
Watson has a life outside of Sherlock, you know, like. He can do his own thing.
Just like Sherlock Holmes.
Yeah. Well, Sherlock Holmes is great, but Watson's also a good guy. So, yeah, Watson because of Sherlock. But then I realized that Watson was also that robot that played Jeopardy. And then I realized Emma Watson played Hermione in all of the Harry Potter movies. And then I realized that Watson and Crick discovered the double helix.
Oh, okay. I was going to say, that just sounded like free association right there. That didn't sound like anything.
No, it's a bunch of famous Watsons.
Yeah.
Yeah. And
now there's Watson.
And now here's Watson. So this is a reference to whatever you want. There's a bunch to choose from. Also, I would be remiss if I did not mention that Watson and Crick get all of the credit for finding out the structure of DNA, that double helix twisty shape. But they were they were helped out quite a bit by a woman named
Rosalind Lynn.
Rosalind Franklin, which I asked Kevin to remember for me.
Yeah, don't worry, I gotcha.
So she was also instrumental in finding out about the structure of DNA. Very not famous woman in STEM, unfortunately. She actually passed away before the Nobel Prize was awarded to Watson and Crick. There was a lot of sexism that happened in her life. You should read more about her.
What year was that? Well, actually, continue with the quest at the same time, but what year was that?
The 50s, I believe.
Okay.
But she was, by the time they awarded the Nobel Prize, she had passed away, and they do not give Nobel Prizes posthumously, or at least they didn't at that time, so she did not get credit then. But
Gotcha.
We're giving her credit now. So Watson and Crick and Franklin. and probably some other people.
Okay, but then what is this quest about?
Let's do the quest. Claire, what have you got for us? All right.
She's not fixed. You lied to me.
Claire has a special idle animation. She is holding some invisible dog leashes here and looking at her dogs, which you can't see. But trust me, they're there. It's fine. All right, so let's start this quest. Excuse me, you're a student at Tyto Academy, aren't you? I sure am. Oh, thank goodness. You wouldn't happen to have a moment to talk, would you? It's totally fine if you don't. I just kind of need help with something. Well, here I am. Well, here's the thing. Lay it on me. I'm kind of thinking about trying to maybe send an application to Tyto Academy to study. You know, as a student? Really? That's great. I am kind of excited about it. I've been thinking about it for a long time. My father was a Tytonian, but when I was old enough to apply, I kind of wanted to do my own thing. I started this dog walking business, and I love it, but I guess I just want to try a lot of different things in life. So, as part of my admission application, I have to present a report based on the research I've done. So, you want a food web or something? No, nothing like that. I actually have a pretty cool idea, or at least I think so. Maybe other people will think it's dumb, especially since, well, I'm not sure I'm going to be able to present the data myself. I don't think I understand. It's just, I'm not very good at talking to people, and there are going to be a bunch of scientists from the academy there, and they're going to be judging my work, and I just can't face that on my own. So you want a Tyto student to present the data? Oh my gosh, would you? That would be so helpful. You have no idea how worried I've been about this. Let's get started. Let's do this? Okay, let me explain my data. For the past few months, I've been mapping out the genomes of some of my sweet dogs.
3 of these options are very similar.
They're
very similar.
nuanced.
I like doggos.
All right. Yay, doggos!
Yeah.
Yay!
Thanks, Claire.
Through my research, I've discovered some interesting things about how genes can affect traits in different ways. Why don't you give Parker and Watson there a scan, and I'll show you what I mean. Sounds like fun. Let's accept this quest. All right.
3 exclamation points of fun.
Yes. No more, no less. All right, let's scan Parker
These
and
particle
Watson.
systems. It's pretty good.
Okay. Parker.
Parker is a good boy. What about Watson?
Parker here has a capital B eye color genotype, which gives him his brown eyes. Watson is a good girl. Scan. As you can see, Watson has blue eyes. Interestingly, she has the same dominant brown eye allele as Parker. And you can see what people have said in this chat box.
That is actually super useful.
Yes.
For the record.
All right. So to recap, Parker and Watson both have a dominant brown eye allele for their eye color, which means that both of them should have brown eyes. But for some reason, Watson's are blue. So let's see what Claire found out about why that might be. Isn't that interesting? Both dogs have the genes for brown eyes, yet Watson's eyes are blue. Why do you think that is?
Yeah, that's a really good answer.
Not quite.
It's the future.
It is the future. I did a lot of research on this topic. Pigment is a chemical that controls color. Normally, the more pigment in an area, the darker the area is. I also discovered that Watson possesses something called the Merle gene. The Merle gene affects the dog's ability to produce pigment in certain areas of its body. Both dogs have the genes for brown pigment in their eyes, but the Merle gene is keeping Watson's eyes from producing that pigment. That's what makes her eyes blue. That's pretty amazing, Claire.
Is there a point to all this?
You know what? Shush. Be polite.
I was just reading
Claire.
the other... You wrote that.
I know I wrote that, and I didn't select it because it's very rude. I also wrote it with help from Josh. To keep
Oh, okay.
So thank you, Josh. Thanks. In genetics, this concept is called polygenic influence. Polygenic influence describes what happens when multiple alleles influence the way a certain trait is displayed. In this case, the Merle gene is contributing to Watson's eye color, just like the actual eye color gene would. I see. Why don't you fill out a Punnett square for Watson and Parker and see if you can tell me what might happen if they were to have puppies together?
Oh my gosh, Claire.
All right, so I'm about to do this Punnett square, and it's going to look a little different from Punnett squares that we have done in the past. Are you ready?
No.
I'm going to do it. Ready,
Oh.
set.
Oh my
snap.
gosh.
What's this?
I'm
This-
being timed on this?
Yes, you are, but you have 3 minutes to do it.
Oh my gosh. I had 3 minutes to do the last one, didn't I? Or was
No,
it
you have-
30
you have
seconds?
30 seconds to
Oh,
do
okay.
the last one. So this is a 4x4 Punnett square. We have a quest that deals specifically with how to do these and how to go about doing these, but basically it's much the same as a 2x2. You look for the row and the column, and then you find the card that corresponds. It's just that there are 2 letters to see instead of just one. So I'm going to do this
Whoa.
as quickly as I can here. Let's see if
We've already used up 30 seconds.
it'll be fine.
I'm already freaking out. It doesn't matter.
There we go.
Oh my gosh.
We're getting
Wait,
this.
is there a pattern here? Can you only... Oh.
Hmm?
Never mind. Keep going. Don't pay attention to me.
All right, I will not. I will leave you behind.
So this is like a memory game, matching memory game.
Kind of,
sorta.
except that all of the cards are flipped over and very similar.
Yeah. Oh, okay.
No. And ta-da! 2 of 3
Oh, I
stars.
see. Ooh. Hmm.
Yeah, yeah. Well, I'm not going to retry it because that would be tedious, but you can.
But you
retry
can
it if
retry.
you so desire. And the amount of research points you get from quests will be different according to how well you do on these particular puzzles.
So you want to get 3 stars all the time.
Yes. All right. So
What is this? I solved your puzzle, Claire.
this is predicting what it might look like if Parker and Watson were to have
Oh, okay.
puppies. So this is our probability analysis. Again, this is much the same as our 2x2 squares used to be, except that there's some more letters in play. So let's look at our key. Capital B is brown eyes, and capital M is an active Merle gene, and lowercase b is blue, and lowercase m is actually inactive Merle gene, not nactive Merle gene. The eye is there; it's getting cut off. So this is.
It's very tiny
Yeah,
eye.
as you
It's a
can see,
very
there are
thin
a couple
eye.
of letters. There are some letters that are being cut off here just because the cards aren't. This is the widest letter that we could have used, and there's 2 of them together.
Oh,
so
jeez.
it was not designed for the letters
Smaller
M.
fonts.
All right, so
Sorry, real quick question, and Claire may have said this already, so I apologize. Do you know why it's called Merle gene?
I do not actually. Do you know why it's called the Merle gene? Guy
No,
who's
that's
sitting
why
at
I
a
asked
computer.
you.
You're sitting at an
Oh, that's true. I can
encyclopedia.
look it up.
All right, well,
Hang
you
on.
look it up. I'll just explain here what's going on. So we want to see what the probability of having brown eyes is. Now we know from Watson that if you have a capital B brown eye gene or brown eye allele as well as a capital M Merle allele, then that will mean that you have Merle eyes. So the Merle sort of overrides the B here. So we're looking for capital B's without capital M's. So here's 4 here, and there's 4 over here as well. That makes 8. So we're going to say 8. Analyze. Oh, no, I did it wrong. Oh, no. Oh, no, indeed. Well, let's do the Merle gene instead then. This is math. I know that these get kind of complicated, but...
Well, I've been too busy looking up the history of Merle gene. Seems like it's specific to dogs.
There are different animals that can be Merles, but...
It says Merle is a pattern in a dog's coat. Oh, but it's for the dog coat, parenthetical. That's a little bit confusing. Whatever, keep solving your puzzles. I'm going to solve this mystery. They are all pictures of dogs.
All right, here we go. We got 8 for the inactive Merle gene.
It doesn't seem to
Just
say
these
why
ones.
it's named after Merle, which is what I was concerned with.
I guess that the brown gene is actually active in all of them. Oh, I tricked myself. Look at that. All right. Yes.
Well done.
There
That's
is
just
a brown
good
gene
design
for all
right
of
there.
them, but yup. But the Merle gene counteracts some of them. So now we're looking for capital M's for the Merle gene, and that is here on this row and here on this row.
Oh.
And there aren't any on these, so that makes 8. Let's analyze it. There we go. I did it. I did my own puzzle, everybody.
Well done.
So if Watson and Parker were to have puppies, all of them would have the brown eye gene, but there's a 50-50 chance or an 8 in 16 chance or half or 50% half chance that they will have blue eyes because of Watson's
Merle gene.
So yeah, let's speak with Claire again.
We've been here all day.
We have, yeah. Great job. So when do you think you could present my data for me? I still have 2 weeks before it's due, so any time that's convenient for you would be fine with me. Maybe next Tuesday? I think you are ready to present your data, Claire.
Whoa.
What? I'm not going to be able to present this to the Academy scientists. I can't.
Come on, Claire. Grow a backbone.
Oh,
You got this, Claire.
you presented it so well to me. But it's different because, I mean, I know you're technically a scientist too, and I did just present all my data to you, but you know what? You're right. Maybe I can do this myself. It is my data after all. Thank you for the boost of confidence.
Break a leg.
Break a leg. All right. We did it. We
Grow
helped
backbone.
Claire. And hopefully she'll be able to get into the academy. And before I leave, everybody needs to see the insignia on the back of Claire's
Caroline
outfit
worked
here.
very hard
I
on this
did.
insignia.
This is one of the few models in this game that I textured all by myself. So, yeah, I worked
It is a
real
good
hard
texture.
on this. Well, thank you.
It was a good
Yes,
texture.
Got a corgi.
I
the
did
best
reduce the
dog.
resolution on it.
Yes, you did. Ruining my good stuff. Kevin, ruiner of art.
So we're walking to another quest now, right?
We are, yes.
So we didn't solve the mystery of whatever the Merle gene is, or why it's named that. But I'm curious as to why dog walker is a specific occupation aspect that has all this exotic fauna. Like, why are we restricted to dogs still?
Well,
What about a Ketrix walker?
Ketrices or Ketrixi or however you say them, they are extremely rare in Esbeth. It would be probably illegal to have one as a pet.
Draken walker?
Dragons fly, and you can't really walk. But like,
Put a
where
leash on them.
would you put a leash on this body type exactly? Like, you just
Anywhere.
get angry, and it's strange. Their little necks. It'd be very sad to put a draken on a leash. But yeah, when we traveled from Earth, of course we brought dogs because of course we did. Why am I?
Because they are perfect creatures.
They are. Look at this. Look at this majestic animal. Good old
He's
Hilo.
walking a little bit fast.
A little bit, but he's got places to be.
Wait, so where's the next quest?
The next quest is in this
Oh,
corner.
okay,
I'm
good.
so used to going over to Hiroshi that I forgot that the quest is
Yeah.
actually in this corner with Tyto student Asa, who has been standing here since the academy was built, but hasn't had a quest yet. So
The academy
two
was built
newbies.
around her.
Yes. All right, Asa. Hello, old sport. Hello to you too.
What?
I'm trying out new catchphrases. What do you think?
Yeah, that's a really good one.
Think old
Asa.
sport is fine?
No,
No.
I was being a little bit sarcastic. What was your old catchphrase?
What was your old catchphrase? I've never had a catchphrase before. That's why I'm trying this one out, old sport.
I don't like Asa.
Being unique is very important to me, you see. I always need to stand out from the crowd. Do you prefer to blend in, or are you the same way, Kevin?
I can understand that
I
feeling.
can understand that feeling. The need to be noticed, to be remembered and admired, to leave a mark that's different from anyone else's, that's what makes me tick. I guess I'm a lot like a Gepetto, huh? A Gepetto.
Yeah, old sport.
Uh-oh.
What? Was that broken?
Yes.
Oh, okay.
All right, what do you mean? Oh, no.
Oh, no.
Oh, gosh.
Oh, it's all broken?
It's all broken. This must have broken recently then. That's very sad
It's
for
live
us.
TV, folks.
It is live TV. Yep. I prefer to blend in. What do you mean? Okay, thank goodness. All right.
Wait, it might break here, though.
It might.
It could break anywhere.
We'll see. Take those Gepettos outside of the academy, for instance. They're all pink, but if you look closely, you can see that each one has a slightly different shade. Some are light pink, some are bright pink, some are in between. Being unique must be in their DNA. Huh, I'd never noticed. Well, I mean, it's probably genetic, right? I bet that each one develops a different genotype so that they're sure to be different from all the others. It's not really how heredity works. I'm a new student at Tyto, so I haven't covered heredity in depth yet. Now I'm curious, what makes those Gepettos appear differently? I bet they all have different color genotypes. That would explain it. That would explain it.
That would explain it.
Hey, like I said, I'm still pretty new around here, so I haven't got my own scanner, but I see that you have one. Why don't you go out there, scan the Gepettos, and see if they all have different genotypes? All right, sounds fun. Let's go check out these Gepettos. These Gepettos are right outside the window, and Asa is too short to look out the window, but that's fine. We'll just, she can see them from outside. Gonna go and
Can
look
stare
at
out the
these
window
Gepettos.
longingly. She kind of stopped saying old sport after a little bit. I really did appreciate that. Oh, you still got her highlighted too.
No, I don't.
She can see you through the window.
All right. So let's go to this location on our map, and as you can kind of see, it's nighttime now, so it's
You
a
have
bit
arrived
hard
at the
to see.
Gepettos location.
We can see we have a pale pink Geppetto
Oh yeah,
here.
look at that.
Geppetto.
Just
That's how they usually look.
Vanilla Gepetto.
And there are some bright pink Geppettos over here. You can see them a little better in the day, but we made special Geppetto textures just for this quest. So that you can see that they are all pink. They're all like basically the same color scheme, but they do have slightly different...
More saturated.
Yeah, more saturated or less saturated. So, so yeah. We're going to get our DNA extractor out here. And we're going to get some
Poor
Geppetto
Gepettos.
DNA. So we've got that DNA
That
now.
freeze particle effect is that new? I don't
And,
remember seeing that.
We notice that all of the Gepettos have the same genotype for color. So I guess that means that Ace's hypothesis is incorrect, because she thought that all of the Gepettos would have different genotypes, and that's what makes them different colors. But they're all the same. So why do they have different colors? This is
that
most irregular.
phenotype?
It is, but no.
Oh, okay. Live TV, folks.
Live TV. We're walking. This is a good thing. Walking is good.
I don't know. I feel like if you could get around faster, that'd be preferable.
Nonsense. All right, Asa. You're back! While you were gone, I decided to look up some information on genetics. What did you find out? I bet if we put our heads together, we can better understand these fabulous feathered features. The Gepettos all have the same color genotype. Oh ho! In that case, it looks like my original hypothesis was incorrect. But that doesn't explain the color differences. I actually read about a phenomenon called variable expressivity while you were gone. It was so convenient.
I was gone for like 5 minutes.
She's got a smartphone.
Oh, okay.
I think it has to do with what's happening to the Gepettos. Oh, explain. You see, many traits operate like light switches. They're either on or off. You have blue eyes or you don't, you're right-handed or you're not, etc.
You right-handed.
Is that what it said?
Yeah.
No, it didn't. Shush.
Well, okay.
No, be quiet.
I have recording.
Oh, no, you're
I
right.
can actually go back and... Yeah, it says you right-handed. It says it on the stream right
Dang
now.
it. I'll fix that. Don't worry, everybody. Some genes function more like dimmer switches, however. They're either on or off, but they can be stronger or weaker depending on a lot of factors. What kinds of factors? What I'm saying is this. It seems like genetics can be more complex and imprecise than we often think. These Gepettos all share a genotype, an environment, a diet, and even a family, and yet they still manage to be unique.
Why did we go out there to figure this stuff out, and then Asa's over here just figuring all the other stuff out?
Well, she thought that if you went out there to, you'd find out that they had different genotypes, and that would prove her theory.
And then she just made a thesis. She wrote an essay in 5 minutes explaining why she was originally wrong and why we're actually wrong.
Wow, science is amazing, Buddy Roo. Huh?
I don't like any of these. I guess Buddy Roo. Buddy Roo?
Yeah, I'm trying it out. I may not know why each Gepetto is unique, but I still admire their style, and I still want to work on my catchphrase.
Yeah.
You do you, Asa.
Or just not have one.
All right, so in that quest we learned about variable expressivity. That is it's I guess a phenomenon. It's sort of hard to explain, but
put it on the tally.
You might find when you are breeding your Drakens that some of them have the same color genotype, but they'll be a little bit different in hue and in shade, and that's variable expressivity. It's often used to describe certain types of inheritable diseases. Sometimes you can have the gene for certain diseases, but it can be more severe or less severe, and science isn't sure what exactly is controlling that. It seems to just be random, I guess. So yeah, that's variable expressivity, and it's just one more reason why science is very complicated and confusing and awesome. So yeah, these are the 2 quests that I wanted to show everybody.
Okay, so those were all the quests we were going to show?
Yes.
Just making
Yes,
sure.
indeed
Okay,
they were.
cool. So we learned about, as you said, variable expressivity and Merle.
And Merle. We learned about some genes that are influenced, or some phenotypes, I guess, that are influenced by more than one gene. For instance, the eyes had the brown genotype, but they were also receiving information from this Merle gene that can be active or inactive in those 2 dogs. So.
Okay, cool.
So yeah, we have learned those things, and it is a bright new day in Espeth. The sun
So,
is shining.
well, to wrap it all up, Is there anything going on with, like anything to look forward to in the future? For me, particularly, I'm curious about Drakens. Um, but I don't know where we're at in terms of feature lists and whatnot and what's planned.
We are rolling out new features for Drakens every week, or every 2 weeks, I guess. And we are each level that you progress in Heredity will unlock a new Draken gene. And by the time you get to level 6, you will be able to access one of our secret genes, but I will not reveal what that gene is. So,
But it does exist.
It does exist. So you can start breeding that into your Draconarium by going through the lookbook, finding some Drakens with a genotype that you want to explore, I guess, and then go to it. So yeah, you can start trying all of that out, and we are still working on Draken genes, but we'll be wrapping that up soon, and then you'll just have a fully functional Draconarium to
Hopefully.
play around with.
Hopefully.
Oh, one thing that I don't think we mentioned, I'm not going to visit my Draconarium. I have some Drakens that are displaying secret characteristics, and I want to leave them a surprise.
Oh, okay.
But you can feed your Drakens now, and you can also beckon them towards you. So it used to be that they would fly around in your aviary. You could click on them, but that wouldn't do anything, and you had to just remember what their faces look like. Now, if you click on a Draken, you will select it, and you can beckon it towards you. It'll come towards you very obediently. You can also feed it one of 4 types of treats. These treats cost research points to feed to your Draken, and they can affect the way that your Draken's colors are displayed. So if you get a Draken whose colors are a little bit off from what you would like them to be, you can feed them some treats to nudge that color one direction or the other.
Gotcha.
You cannot change your Draken's color genotype, but you will be able to sort of affect the variable expressivity within your genotype. And the phenotype, yes. So the variable expressivity of the phenotype, I guess, you will be able to affect that with your little candies.
Okay, cool. Well,
So,
then, I assume that's everything we want to show.
That
I guess
is,
we'll wrap
that
it
is
up
everything.
here. Thanks for joining us, you guys. Again, Immerse Games live stream every 2 weeks, every Thursday.
Every other Thursday.
Six-ish. Oh, yeah, every
6-ish,
other Thursday, every 2 weeks.
Yeah, fortnightly.
Yeah. But yeah, thanks for joining us, and we will see you guys next time.